TikTok is now online.
End of line.
All right, hello everyone. I would like to make sure I have everything functional here, so give me one moment. Let's see, just checking a couple of things here. Okay. All right, so let me close. Apparently it doesn't, Desiac. I'm gonna guess the cable is loose. No. I don't know. That's weird. The phone is getting power. I'm gonna guess the network thing changed, and now that's gonna be in the history. Okay.
100. Everything functional except chat. We're dysfunctional.
End of line.
Okay. Good. It skipped Desiac. Yes, that's exactly what we want. All right. Real quick. Let's just disable that. Since it doesn't work. I'm going to guess the network cable going to the SPA interface for the phone thing. It's not plugged in, and I don't want to try and go back there right now. So, okay. Chloe, thank you for the 100 bits. I appreciate that. All right, so for those of you who may not have been here yesterday, let me walk you through what we have going. That was really confusing, Dziak, because that kind of happened right as you type that. Anyway, yesterday we were working on trying to make a bootable floppy disk for the Micronova. And to do that, we need 2 floppy drives to be functional, because the first floppy drive boots and has the live DOS system on it. And then we need the second disk to have a sysgen application on it. Now, I believe we don't have enough storage on one disk to fit the live DOS operating system and sysgen and the resulting sysgen output. So I don't think that we can do that all on one disk. So I've been trying to come up with a way of doing it with 2 drives and 2 disks. When we finally started on that process yesterday, we discovered that there is some kind of issue with the second drive in the machine. It reports it is right-locked in the operating system, but not on the hardware. There are LEDs on, well, the board up here that light when the drive reports the right lock through the right lock sensor on here. That seems fine, but on the operating system, it reports that it can't write to the disk. My suspicion says that, oh, you need 2 drives to sysgen on a floppy-only system. Okay, weird. But that also is with their disks. They don't expect you to have cobbled together your own nonsense, so who knows. So here's the thing, we can't, the operating system will not boot on this disk because it writes temporary files, or won't boot on this drive because it writes temporary files to the disk when you boot. So even if we can't write on this one, we still can't use the other one to just make the sysgen. So we have to get the second drive to be able to write. Now, yeah, you have to buy the right license for the second drive, yeah. I have a suspicion of what the issue is with the second drive write. I believe the erase head is not working. So the first thing we're going to do here is we're going to take out both drives, and we're going to run them simultaneously out of the rack or unit and measure the erase head signal going to the drives when we try to boot the machine with both drives, because during the boot process it should try to run or try to modify the disk. So we should see something. So minimum required files, it just barely doesn't have the room to build. It's unfortunate. All right, good to know. Thank you for trying that. 0. All right, stupid question out of the way from the start. No way you can make a GoTech. No. No. So for anyone who sees like, oh, they're standard 50 pin. No. No, they're not. I want you to think about this, all right? I don't think these are standard 50 pin.
JOAOSOMPRA 7121 subbed as tier 1 and says liking the Data General Live series.
End of line.
Joust number, thank you for the tier 1 sub and for 32 months. I appreciate that. So we have 2 cables that plug in to the drives. We have the 50 pin cable and we have the 120 volts AC cable. That's it. That means that power is carried over that for all of the digital stuff. Now, I don't think that that's standard. At least, I'm pretty sure none of my other drives do that. So, I don't think that these are a standard interface floppy. Because, again, logic power is carried over these connectors. So, any other drive I have that I could put in there would get roasted. Power over floppy cable, again, yes, it is, in fact, the evil returning once more. So that's why I'm not really looking into that. Additionally, the closest drives I have to these are Shugart SA800s that I've never tested. So I don't think that it would be a good idea to do that. Anyway, also the other problem is that the power connectors for 8-inch floppy drives are not even remotely standardized. So even if we did have a power connector...
It's that time again.
End of line.
Even if we did have a power connector, it would be different, and I would have to modify the chassis to be able to power it. Pordizo, thank you for the tier 1 sub and for 38 months. Holy moly, that is a, that's this many months. Thank you. CC Manga for the drive did mention regular 50 pin, but there may be some different variants. Yeah, well, there's definitely different variants of it. There's like a whole config table in there. So, yeah. Okay. So that's where we are at. Currently, the machine is set up with the both drives in there with the cables flipped. Sure. If we can flip and flop, then it can be flopped. Anyway, yeah. Drive 1 and 0 get swapped? Yes. And the problem follows the drive, not the controller. Yeah, it is swapped right now, actually. If we
look tier 1 and says woo.
End of line.
So if you look right here, you'll see that the cables are reaching over each other. That's not the standard configuration. So, Nesreal, thank you for the tier 1 sub and for 33 months. I appreciate that.
Chlorocoon says CHEER 100 floppy cables are flipped and the flippy cables are flopped.
End of line.
Chloe, thank you for the 100 bits. I mean, IBM PC floppy cables are flopped or flipped. All right. Let's don the ESD strap once again and continue. For those of you who will know what I'm talking about, which I think is 3 people, and 2 of them are here, we're currently using option A. Option B actually isn't compatible with live streams. Another reason I'm probably never going to use option B. Okay. Yeah, I think this is it. All right. I am now recording, by the way. So, yeah, I'll be doing video call-outs here. Yeah. Jeez. All right, so I need to get the unit disassembled in such a way that we can have the logic board connected to power, but have both drives out and accessible because they have control boards on the bottom, but the bottom of this case is actually one solid piece that wraps all the way around. It is impossible to gain access to the bottom of the floppy drives with them installed. So the first thing I'm going to do here is fully remove the drive controller PCB, and then we will work on extracting both of the floppy drives. That is a monstrous PCB.
Emulate says CHEER 100 hype train.
End of line.
Emulate ATG, thank you for the 100 bits there. I appreciate that. All right, now I've already removed the screws from the bad drive for diagnostic purposes, so I'm going to go ahead and get that one out immediately, and then we'll have to unbolt that one from the bottom. Oh my gosh. It's still so heavy even with only one drive installed. So Philip, it shouldn't be possible because there's a shield between the board and the drives. So what you're seeing is not a complete setup. So there's a like 16th gauge metal shield. Where's the screw container?
Chlorocoon says CHEER 100. Welcome to the Shelby weightlifting channel.
End of line.
Yeah, no kidding. Where is the screw container? How did I lose it? Huh. Oh, there it is. Each drive, well, the two big 120 fans have, or motors have fans for forced cooling, yes. Yeah, was a thought. Yeah. There are a lot of thoughts for this. Oh, we're going to have to clean this one. Because it should still be super gross. I think I just lost the washer. That's fine. There it is. Oh. There doesn't need to be, but it feels like there should be like a split here so that the drives can't just like slide across. I don't know why, but that just feels weird. All right. There is one naked Data General 6039. You know, I hopefully will never get another opportunity to clean the inside of this, so let's just go ahead and do that right now. Any way to add an HDD to this? Yeah, plug it in. That's a hard drive right there. Plug it in. That's how. But before we do that, we got a lot of restoration work on that thing. Redact the stream. What are you talking about? We got the brushes and everything here. We're good. Oh, for the naked floppy. Gotcha. Oh, whoops. Sorry, stickers. That high potted I got. I don't know, man. Okay. I'll call this out as usual. This is not your everyday run-of-the-mill vacuum cleaner. This is a specially made ESD safe vacuum cleaner for working on electronics. It is grounded from the tip to mains earth ground. So it is safe to use for an application like this. A normal vacuum cleaner is not. I think I'm gonna call that
CRACYBOY 2025 gave a tier 1 gift sub to Animoy.
End of line.
Crazy Boy. Thank you for the gifted sub. I appreciate that. Note if you have to use an ultrasonic cleaner today, does that technically make this a hot tub stream? It's the most maintenance has had several decades, possibly ever. I don't think there are any records of maintenance on the floppy drive in the service notes. I somehow managed to miss part. There. There's nowhere to grab on the back. Now I'm going to pull this aside for the moment, because I've already cleaned the bottom of the drive that is not functional, and I know that that means the bottom of this one is gonna be gross. So let's clean this up as well.
CRAVYBOY 2025 FFS Tier 1 for 5 months and says,
End of line.
Crazy Boy, thank you for the tier 1 sub yourself as well. And for 5 months there, I think I heard it say. It doesn't say that on the back end, but if it's 5 months, thank you. All right. That should be it for cleaning for now. From here, I think everything else is good enough to go over. I would, however, though, like to get a photo of the top and bottom of this board that are actually really good. I took a picture of the top side of this board before I left yesterday so that I could start tracing out what we need to work on. And the pin here kind of, you know, goes all over, but I know of a couple places that it should be going. But if I have to get deeper into this, I think some reference material would be really nice to have. So let's try and figure that out here. So Willie Ken, the hard drive is going to be extremely difficult to get up and running. So we're putting that off for as long as possible. Wow, it's actually still pretty dirty. I thought like, oh, it's way better. And then I see that there's like, you know, just stuff in there. It's just all over. They'll never be clean again. HDD is probably dead. That's not necessarily true. The bottom platter has no signs of damage. The bottom head of the bottom platter looks good, and the platter's top side looks good, which is a pretty strong indicator that it should be okay. Okay. Now, we have screws here, and then I don't know what these go into. They move, so I don't think they attach to the cast pot metal chassis thing. So I think if I undo those and then pinch all of the plastic standoffs and pull on the board, I think it'll come up. So let's try and do that. Somebody left their screwdriver over there.
LUCKYBOB 77 SIZHEER 100. Man, if I had $1 for every time I said it should be okay.
End of line.
Lucky Bob, thank you for the 100 bits. Love the gray plastic gold-legged TO2. Oh, these? They are pretty darn gray. Those are Motorola's T220. But yeah. I really like this Beckman chip here that's just gray. I don't know why. That looks really cool to me. All right. This is the bad unit, by the way. Because if we're, you know, gonna poke around anything. Let's poke around the one that is less likely to be damaged by it. Okay, that did fully loosen the board, so I think this will work. Now we just have to not destroy the plastic standoffs. Wish I had like a little plastic tube or something. Maybe tweezers. I wonder if they'd be strong enough to pinch him.
CRAZYPOY 2025 SICHER 100 in Z80012 using X rather than binary and converting to a basic SC2 code utilizing IE5908B7U.
End of line.
Crazy boy, thank you for the 100 bits. So this thing will actually use octal, weirdly. So it's going to be like a whole other beast. Oh, you know, these actually seem really nice. I don't think I've ever seen any like this. So rather than two sides that splay out, they have to pinch together, it seems like there's just the one Easter Island nose that you pinch, and then the rest of it is fine. So in theory, I just push this in, and then it'll start to lift. In theory. I think it's still kind of wedged on it. There we go.
CRAZYPOY 2025 SICHER 100. Oh, what is that fragrance? It smells divine. WD-40.
End of line.
Thank you for the 100 bits again, Gracie Bob. Big pen, yeah, if I had one of those ready to go, that would work. But these are, yeah, being single-sided actually makes this really, really easy.
CRAZYPOY 2025 SICHER 100. Are you a Red Dwarf fan, Shelby?
End of line.
Yes. All right. Huh. I'm curious to... Man, it's so dirty. We gotta clean it again. Jeez. Ugh. Why is everything so dirty? Other than, you know, time. And these are literally the things where Data General sent a letter saying, it's too dirty, we won't warranty it. Okay. We can just use me. We won't need to clean again. Puts away all the cleaning tools. Also me. Oh, well, gosh, we instantly need to clean again.
CRAZYPOY 2025 SICHER 100. Emergency. There's an emergency going on. It's still going on. Rimmer, you can do sloppy work on the drive plate.
End of line.
Crazy boy, thank you for 100 bits again. Okay. Now we're going to get set up to take some photos. So, let me clear some space. If I'm going to do this, I might as well do it right. Dust completely changed the color. Yeah, there's a lot of dust on there.
CRAZYBOY 2025 SICHER 100 red alert. Forget red alert, go straight to brown.
End of line.
Crazy boy, thank you for the 100 bits once more. All right. This is one of those things where there's no great way for me to film it. So we're going to just hold back for a bit here. No, I didn't want to change exposure. All right. I'm going to pull the camera around here. All right. That's going to be the wrong lens. Let me swap that. Is that a Nova in the back? That's the empty rack for one, because the Nova is on my desk or workbench over here. But also there's a 4X in the bigger, taller rack over there. So there's a micro that we are currently working on. And then a 4X is waiting in the wings to be worked on after. Okay. I don't remember if this is all still connected, so let's find out. Sounds like a show I'd really never enjoy. Somehow I've never managed to watch it. Genuinely, it's incredible. Have you watched the first season of Doctor Who? Let me rephrase that. The first modern season.
TV4X is waiting to extract its damage and shall be back at a later date.
End of line.
Okay, I see what I need to do here. Because Red Dwarf feels a lot like the Eccleston season, and then never really goes away from that, but then is actually funny. Why is this not long enough? That's frustrating. Oh, because I'm an idiot. I plug it into the monitor. Forget, the monitor has USB ports. Watch Eccleston as Doctor on PBS. Yeah, so if you liked that level of production, but wanted it to be funny, that's what Red Dwarf is. Exactly. Philip's got it right there. All right. Now we'll see if this scene works. Hold on. This is weird. Oh, it's locked. What? Reset. Why is it? Oh, it's not visible because it's behind everything. There we go. All right. Okay, so let me pull the ISO way down. All right. Let me grab this. It's only slightly melted. Oh, that'll be perfect. Okay. And now the part that makes it viable, which is right here. I need to push this over. Please work with me, camera. Okay. Nah, I'm gonna have to push this over more. It's gonna mess up my perspective, I think. Why is this so much harder this time? Maybe I can cheat. All right. That's a little bright. So we can change ISO. Let's drop that down to 200. I don't know how we going from 500 to 200 made it pitch black, but okay, something's wonky. Oh, the shutter speed changed. We were at 160. Okay, so now we'll try 320. That's better. Okay. That looks really good. Okay, we're going to go with that. Then I need to flip it over to get the back side, and thankfully this board's fairly flat, so this should work out well. All right. It's a little rotated. Be very, very still. All right, there we go. And then for good measure, we'll go ahead and take x-ray shots, because why not? All right. Oh, I don't have the glass over here, or is it back there? No. Where did I put the glass? Did I put it away correctly? Weirdo. Ah, is the strip. Ah. Yep, I put it all away. It's almost like I don't want to end up with a bunch of broken glass all over the office or something. Okay.
Chlorocoon says CHEER 100 Shelby was at the end of his tether.
End of line.
Chloe, thank you for the 100 bits. There we go. All right. I've counted stream while I thought you were about to pull out literal x-ray machine. I mean, one day, sure, find one at Goodwill.
CRAZYBOY 2025 SICHEER 100 Shelby. Did you see the DG Nova Celtcon display on Epe?
End of line.
You mean the Burroughs alphanumeric Panoplex display thing? No, I don't know what you're talking about. Yeah, if that is a yes, that will never work with anything ever again. So, doesn't really matter. All right. I think that's all in focus. Oh, wait, let's do the thing that I wish I remembered to do last time. Hold on. I forgot. I was so mad at myself I didn't do this the last time I did backlit shots. Having front light at all just kills it. That's so much better. Okay. Wow, that's any color. Oh wait, no, that's not live image. So say any color you can see, it's just a reflection off of the ceiling. There's not a lot I can do about that. There we go. Oh, that's so much better. Looks like I'm holding a keytar. Hold on, let me just, there we go. Oh, that's so much better. Okay. Why not? But you don't have the interface needed for the Panoplex display. If I remember correctly, it looked weird. So it's not just going to be an RS-232 port. Ah. Okay. All right. That will do. There we go. This time you could see like the what happens if I make this bigger? I can't tell because OBS is behind it. Okay, it does make it larger on OBS. I'm just going to hope for the best here. Next to the J2 connector, the MOSFET, or the green square in the black area to the left of that, you can see the transistor. You can also read the number printed onto there. The only light that is in here that's getting onto that thing is just a reflection from the ceiling. That's it. All right, we'll call that good enough and go back to your regularly scheduled programming here. Let me turn these back on. Okay. By the way, I mention every now and then that when I'm doing these streams, I'm basically staring at the sun the whole time. This is what it would look like if I did not have the front lights. Except it would look more like this. Both sides with lights off? Yes, I did. Good call, though, to double check, because, yeah, that would be annoying to not have that. Ah, okay. It is quite handy to have all of that at the ready for doing high quality documentation shots like that. All right, now I should probably turn on the front lights. Oh, let me go get my sunglasses. It's so nice not staring directly into lights, but I need them. Okay, sending a link for digital x-ray machine local pickup. How many digits are in the price? Okay. 5. Yeah, I think pass. Let's see. I want to actually work on those a little bit here before we start probing around. I started doing this somewhat last night, but I did not have the manual is on eBay, that it is not for my CPU. That is a different CPU, so it's not relevant. Anyway, I want to go look at those images more directly and set them up so that we can do some tracing, because I would rather not just do this blind. So let's actually form a little plan here. So I'm just gonna click this, hit this, click that, and then do that. Okay. Wow. Alrighty. One moment here. Oh, it feels really nice to not be wearing the ESD strap. It's cool when your arm isn't being squeezed constantly. All right. Backpack. This is a Kubuntu background. All right, now the images aren't on this computer, so one moment while I transfer them over. I have an SSD or that kind of thing somewhere in my bag over here, theoretically. There it is. Okay, got it. It's illegal in Arizona to own an X-ray machine. It isn't in Australia? I mean, pretty sure I'm gonna guess that it is, and that it's let me phrase it this way, only gonna get more legal. All right, hold on, I just need to copy the files. Thought I could do it from over there. I was wrong. Okay, pictures, capture. Everything that was recent. Ooh, we're gonna do something weird. All right, I slightly regret saying that I'm gonna do this because it's gonna make life difficult, but I want to use raw therapy to look at the raw files. Ugh, it's gonna be a nightmare. New folder, CDC floppy. Done. Safely remove. There we go. All right. Okay. Did I stop using coffee at the streams? I like how you say using. Like, I don't think of it as a drug, but like, but that phrasing. I do have coffee now that you mention it though, but now you make me feel bad about it. All right. I have started on some of this a little bit, so you'll understand why I kind of wanted better photos. We'll get into this later. You know, I'm curious. I'm going to open this with GIMP because I think Gwenview just screwed that up. Yeah. What gives, Gwenview? Apparently it doesn't do masks. Weird. All right. Let's do this really quick. Sudo apt install raw therapy. Yeah, raw therapy. For a second I thought, wait, do I want UF raw? No, I'm pretty sure I want raw therapy. We do have a schematic, but I would like to... I don't want to just look at the schematic and then probe around. I want to draw over the traces first so that I can just have the schematic's relevant components right there and visible. So this is the manual or service document for that floppy drive. And the relevant part of the schematic is right here. So that red stuff I'd shown you there, I'd traced all the way back to about here on it. It's kind of weird, and I wanted to see both sides of the board because I was making some guesses and I wasn't really thrilled about it. So, okay, let's try this. Open with raw therapy. Just kind of curious. This is how you're supposed to open and edit RAWs on Linux, but I never do it. And do we want to retake the photos? Huh. Drat. What's this one look like? That one's better. So it's still really hard to see, geez. So either I bumped the table or the shutter shook this, because that's not right. Why is shift scroll and control scroll zoom? Why is one of them not horizontal scroll? This is the kind of thing where every time I try raw therapy, I'm like, the software sucks. And then I go to GIMP. Look at this one. That's better, a little overexposed, but we'll probably just use that one if everything else looks fine. Oh, that's so good. Ooh, okay, a little bit of shutter shimmy. It's fine enough. Oh, that's nice. Thumb wheel scroll? I don't have a scroll thumb wheel. It's an MX518. That wasn't invented yet. All right. I am instantly disinterested in using raw therapy, so on the GIMP. Like, just even opening the software, I'm like, oh. I don't want to hate it, but, like, it's never a good experience. That one's better. We'll compare those. Then that one's flipped, right? Yeah. And good enough. Okay. MX Master 3, do you like it? Oh, yeah, I have two MX Master 3Ss. I just don't feel like spending another $100 on one just to have one at the office. There's one in my laptop bag over there right now for my laptop, but yeah. On the other hand, though, I'm kind of tired of the mouse buttons dying and the rubber coating turning to goo. So, yeah, I don't really want to give Logitech any more money. All right, so that one kind of sucks. This one... It's not. That one's sharper. Oh, wait, it's not sharper. That's just like the difference between the, like, relief or something. Well, maybe it's slightly sharper, but you know what? That one's good enough. Okay, we'll delete this one. Okay, no, not both. Okay. All right, welcome to Shelby Teaches You How to Do PCB Reverse Engineering 101. So, step 1, draw a rectangle around the board and touch it to the corners that are the straightest possible edges, because we need straight line references. That sucks right there. I don't like that. That's going to be bad. Okay. So that is as good as that's going to get. Step 2, we're going to go to select, and I'm going to change the size of the window so you can see. Select, invert. So now we have selected the frame around it. I'm going to make sure that I have black, and I'm going to fill in the frame around it with black. So we now have a size that is roughly just the PCB. Okay, now our aspect ratio is going to change slightly with this, but it's going to be pretty close, so we're going to roll with it. Next, we're going to look at the cube tool. The cube tool is perspective, and we're going to wish that this was not stupid, and to make that work, we're going to make the layer that we're working with slightly transparent. Now we just stuff it up into the corners as close as we can possibly get. And that will give us our initial rectangle that we will use for the work. So there we go. Transform. And that should be good enough. Look at this. Flash the layer back and forth. That's looking fine. Okay, so we have our rectangularified. Maybe this corner is slightly too far in, actually. I'm going to undo the perspective there, and I'm going to redo that, and I'm going to push that corner in a little more this time. I'm going to hide that layer as well. So I'm going to pull this over slightly this time, because this card edge didn't go all the way up against the edge of the image. And you know what? I can even do this here, technically. So, all right, now we'll pull this down. There's no real good way for me to know. I think it actually should go over just a little there. All right, back over to here. Put the corner in the corner. Up here, put the corner in the corner. Now you do need to go back and double check your other edges, because the whole thing will slightly change shape as you work on it. You're kind of settling it into the shape. That's pretty close. Okay. Put that one there now. Okay. So we're going to call that good enough for right now. Now we're going to put the bottom side image on top. I am going to do an 50% opacity. I'm going to horizontally flip it. And then we're going to do the same perspective transform, but this time we're going to align one side to the other here. Slightly more opaque. The other thing we could do is, instead of normal, we could do darken only. And that will, actually, I think that's not working when it's in the transform. So that sucks. All right, opacity is our only option. Get this as close as possible. And like I said, you got to go back over the stuff you already did. All right, now, before you lock this in, and you think your corners are good, you should double check the through-hole components, because those will shift around as well. And that's a good reference point, because those should be the same all over. See, these look a little weird, so I'm not sure what's going on over here. I'm going to just drag that kind of, and then see what that changed on the outside edges, because I want to make sure those through holes are in the same position. That's more important than anything else. So that's a good reference one right there. I want to make sure everything else stays aligned. That's a little weird. We're going to fix that there possibly. Same rule applies. The areas that you are not directly working on will be impacted by farther away areas, so you need to double check those. And it may not be possible to get this perfect, but we can get it pretty close. I don't like that. I think we shouldn't have it be impossible to get it right. The only way that would happen is if the board was bent, and I don't think that was, it's not big enough for that. So all right, there we go. That's pretty good. Stony, that's basically it, but we have the schematic. This is, you could do this. This is how I did the, not reset, transform. That's how I did the CM153 card. But this is just helpful for debugging as well, because now we're at the point where we can start drawing traces based on the schematic. So we have this done and locked in. We're going to call this overlaid PCB. Boom. Thankfully, it's just two-plane board. Yeah. So we have J2 right here. All right. Actually, we can get a little slicker here even. Let me grab a file really quick off of my server. That'll make life a lot easier here. Just doing that on the other monitor. DG did give a board image in the manual, but it's just this. There's no traces. Also, this is not a Data General product. It's Control Data Systems or whatever CDC is. Coffee time over, sadly. All right. Doc, and I want this file. Download. All right. PDF extract. This is a very, very handy program. Let's go ahead and put this. Repair, CDC floppy. Actually, we'll put it in the debug folder. There's that. Now, what do I need? I need... Where is it? Oh my gosh, I made this complicated. PDF to whatever that is. All right, tell me what program that's in. Wait, is it installed? Is that just a native? Okay. Native Ubuntu thing? Okay, we want page 40. So we're going to run PDF. We're going to run chmod plus x PDF. So we're going to run PDF extract -I. Actually, let's just do -h first here to get the help. Okay. So -I for the PDF here. We're going to do page range 40 to 40. And then we're going to set our DPI to 1200 because I want a nice high res. Couldn't find trailer dictionary. May not be PDF file continuing anyway. Pretty sure it is. I have never had that happen. Oh, we want 1. Hold on. 41, because it's count. Yeah, but that still didn't do it. That's weird. Why is that not working? Just for giggles, let's try a manual here, CPU Nova 4. What's one that's not insanely large? This? Sure, whatever. Okay, so 08, let's do 008, whatever. Range 1, 1. Couldn't find. Okay, well, that's fun. Oh my gosh, you are right. I'm stupid. All right, first page 40 cannot be after last page 1. Okay, so I had that syntax correct as well. All right, here we go. Now this will work. Blah. All right. Thank you, HoshiTube, for knowing how my own script I wrote works. All right, now we can pop this into GIMP here. Perfect. Okay, because it's a really nice high-res image. Actually, way higher res than my photos. Wow. Okay, I wasn't expecting that. Let's scale that to there. What have I missed? Any further write protect mystery? We are working on a debug process for that right now. Okay. So first thing I'm going to do is I'm going to take this. I'm going to... I can't cut that. Well, we'll just have to deal with it. Image, transform, rotate 180. Okay. Now we'll take layer, transform, rotate 180. Okay. Now we're going to do darken only here. That'll get rid of the white background. And now we want to rotate it 180 again because I'm an idiot. Okay. Darken only. No, I was right. What? Image, transform, rotate 180. It's way, way, way faster to do anything like this not on stream. So much faster. I think I accidentally rotated the image twice. I think that's what happened. All right, here we go. Okay. So this is the manuals, or the service guides, whatever you want to think about it. Document of how this thing works. Why are these all, yeah, shift. So what I want to do is I just want to overlay this on top of the parts because this will give us like a really handy map of where everything is. It's not perfect. I think I need to rotate it from here. Yeah, let's leave it at that scale, and then we'll rotate it. Well, we're not going to reverse engineer this board. That is way beyond the scope of today. So, we're not doing that at all. Okay, not that. Rotate. All we're going to do here is just draw a couple of lines on this after we get this done. I just want it for reference. All right, that's good. Perfect. So the reason is that we need this and why I want to overlay this. All right. Which one is C40? Which one is R24? There ain't nothing on this. Oh, hello. What do we got going on there? There is nothing on this as far as legends for the passive components. So we needed this in order for this to make sense. If we didn't have this, what we would then do is we would go look at the schematic, all right? And then we would be drawing numbers onto our image for the reference designators. We would be relabeling it ourselves. But because we have this handy thing that we can overlay on here, this works out so much better. And then we can also x-ray over to the back to see how this works. Print out the schematic and the bore layout on the same sheet of paper. Yeah, I did something similar but fancier where I printed an x-ray like this and then used a laminator so that I could draw on it with dry erase markers. But I like to go overkill. So, okay, now we can start to figure this out. So, we're going to go ahead and run through this section here. I have already done some of this, so we get to fly through this a little bit here. One thing I'm going to do is I'm going to add a layer that is white here, and we're going to use that to fade the background layer a little bit, and then we can control that level. So, all right. So we need to start with J23. So that is up here, this pin. This is where our erase head signal goes out to the drive. Now, I have not been able to find J24 anywhere on this. If anyone wants to look at this document, here, I'll paste the name of the file in chat in case anyone wants to find it and look at this. If you can find J204, I would be extremely grateful because I cannot find it at all. That link is not going to work. You're going to have to like Google for the file, but yeah, I have no idea where it is. Maybe we could figure it out once we label enough other stuff, but for right now, no clue. So anyway, J203 here, and this is one of those areas where I really wanted to be able to see this. So, okay. We can see that did not go like I thought it would. Okay, this was actually very helpful. So we're going to start out by making our pen red here. We'll make a new draw under. Okay, I immediately regret not having that be transparent. Okay, and then we're going to do draw over. Okay, and then I'm going to do this. Boom. All right, make these 50% opacity. Okay, draw under. So immediately I want to get this marked because that is our starting point. So one thing this is going to do, this is going to tell us all the spots that we can probe the signals. So this is the starting layer here. We can see that, which is boop, CR7. So that is the diode right here that holds that rail up to 12 volts. Yesterday we measured this at 12 volts right there. So we know that diode is working correctly. And we now know that that is a 12 volt rail that goes over to U4. So that's doing some stuff. Okay, where's U4 on here? Can I find that? That could be helpful. Hold on. U4. Let's see. 21, 13, 11, 5. J204 is page 39. That's really far away. No wonder I couldn't find it. 39. You were fast on that season, P or B. Wow. J204 head center tap. Well, that's weird. And there's our plus, yeah, so straight up plus 12. Head center tap. So then J203 must pull current. No. It bumps it up to 24 volts. So this is, why the diode to 12? That's so weird. But anyway, it should be pulled up to 24. So, all right. Whoops. We got that. Okay, so that's unexpected. That's weird. Means the erase head at plus 12 is erase inhibit. Well, not necessarily inhibit, but not functioning. We can't sense inhibit here. There is an erase inhibit signal here we're going to look at in a moment. We also have write inhibit, which is, there's a lot of inhibits here that we have to go through and measure. That's why I wanted to do this. So we know to measure that signal. So that one's kind of blah. We measured that. It didn't really give us anything exciting. So we need to go upstream a little bit more. So let's flip over to the top side here. Boop. All right. So Q1. Yeah, unfortunately, I don't think there's any way for us to know the pinout of this transistor other than we can see which pins the stuff goes to. Although, yeah, so we look at it's R40. And it goes through, R40 is right here. So we're going to go ahead and just mark through here. And then we go to that. All right. I am drawing on the schematic layer. I don't want to do that. All right. We go through there. And then, yep, straight over to there. So we know what that pin is. All right. 24 volt. So we should have a resistor R39 right here that separates, that's on 24 volt on one side, which I don't know if there's a way for us to tell. Well, it has to be this. So this is 24 volt. So I'm going to call or label this plus 24 volt. And I think we determined that was plus 12, or the other side of this, that's plus 12, right? CR 12, yeah, or 7, so that's plus 12. So plus 12 volt. All right. Go back to here. So I just want to work our way back to a control signal. So TP6 here, that one's going to be critical. If I remember, that's, yeah, right there. So that's going to be one of the things that we want to measure for sure. That'll just tell us whether or not the erase head is active, though. So that's not really too dissimilar to actually just measuring the erase head. What we need is to get our way back up to erase inhibit and write inhibit, because one of those are probably the issue. So we want to figure out where that is. But I would also like to be able to probe our way back there. So we were at R41, which is connected to the transistor on the bottom side. Just run through this. Boom. Okay. Now R41 goes to U5, and we will be looking for pin 3, and then pins 1 and 2 are shorted together. It's kind of weird. I'm like trying to use the KiCad. Like, actually, should I just do this in KiCad? I didn't really think of that until just now. Probably. Now that I think about it. So that goes to U5. That's our, I presume, a buffer. TP6 is not for field use. Yeah, I'm sure it isn't. Because if it doesn't write, they tell you just throw it away and buy a new one. Yeah, we're going to get to that in a second here. Again, there's no reference designators anywhere on the board, and I would like to know exactly which pins we want to probe on. I know it's like pin 9 right here. I think that it actually bridges underneath to the bottom side here. Yeah, to R43, that's probably where we'll probe. Again, you're getting ahead of me. Sure, it's not the drive, not enabling the erase head, maybe erases it. See, that's why I want all this marked once, and then we'll have this, then we go over and we take a look. So we're going to do this, and we're going to mark out the points that we want to measure. So I would like to measure, actually, TP6. I would like to measure TP6. So how is that connected? That's what I thought. Okay, so we're going to blue here. So right there. And I'm going to circle that actually as an indication of I want to test on that. Sorry, just flicking through the schematics whilst waiting for coffee. It's right inhibit based on write protect sensor and is separate from the write protect line going back to the controller. Separate from the write protect line. Huh. Write fault occur when the FDD is write enabled and no write data is sent. So that would be write inhibit, or I don't know. Here's the thing that weirds me out the most is that the error happens at the operating system level only. Oh, this is really hard to see. I think it jumps there. So we'll do here to there. And then it jumps all the way over to, I forget what part it is. Wow, that's difficult to see. Is it R26? So that goes to R8 somewhere. Should be tying that high or something. Here's one of the things why I want this marked, because at some point we go over to U10 here, and it's just like, wham, it goes way over there. And I would like to have that path marked, because I speculated on that last night, and it was kind of weird. Where's R8 here? Hold on, I'm going to use my cheat image, because I kind of already did some of this. So let's benefit from that a little bit here. Okay. So, no, I don't want to open it in Gwenview because Gwenview sucks. There. Okay. Yeah. Oh, R8 is over here. See, that's what I was talking about. They're just like, wham, goes way off in the middle of nowhere for some reason. So, yeah, R8 is here. I don't even know how we get from this chip right here all the way over to R8. So let's figure that out. So R8. It's like some long bus line. Jeez. Okay. Under blue. R8 to here, to here, 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 here. So this must jump under the resistor. Dude, one of these days I gotta actually remember to fix it so that GIMP has Control-Shift-Z for forward. That's one of the things that I really wanted to get the double-sided image of, because that helps a lot to understand what is going on there. And then that explains how it gets over to U10 as well. That was very enlightening. So we go down to here, and to here. That should connect to 12 and a resistor and U10. So U10 is a dip 14, I'm presuming. Then we need R27 here. Well, that must connect really awkwardly. It goes under it, I'm guessing here. So boom, and then I know that that also goes over to R28 here, which goes to whatever VREF is. I have no idea. Releasing reverse engineering. I heard a sound like it was, yeah. Just playing with GIMP for the fun of it. Marking up signals of interest. Yes, Ben has it correct there. We're figuring out where we want to probe on the board. Yeah, they're not marked on the board at all. So, yeah, right here, that's probably well, that's the exact same as TP6. So actually, we don't need to measure that. But I would like to measure pin 10 here. So between R30 and pin 10 is definitely a, what went bong? The stream computer for some reason. I don't know why. But yeah, we want probably to measure this, because this also connects to the erase inhibit signal. So yeah, we want pin 10 of this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here for sure is a pin of interest. So we're going to mark that to here, 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 here. And then it also sneaks past that over to there where we won't be able to, oh, we can kind of see it actually. Okay, and that goes down to somewhere I was not expecting. Wait, where's U12? Where's that going? Is that the erase inhibit base signal? It must be. Okay. Huh. Well, we're not going to be able to easily follow that under the chip. We can make some educated guesses, but yeah. I don't think we've stopped streaming, right? Red trace goes to the wrong side of R27. You are correct. 35 minutes initially moved, suggesting that I need coffee. I have so far failed to make coffee happen. How does it get to that side of R27 then? Because we have a trace that goes right through there. That doesn't make sense. Oh, that's awful. It jumps one trace and then goes, dude, did someone drunk lay this board out? Also, I've been screwing up about doing draw under or draw over. So all of this under, yeah, I've been messing this up big time. All right, well, that sucks. Oh, well. Should have just done this in KiCad. There we go. Then it's draw over where these are bridged. Okay. Nah, I don't want to actually do it in KiCad. That's getting a little too committed. I don't know. Yeah, we're too far to switch now for sure. So I'm going to guess this is our source right inhibit signal. So we don't need to follow that anymore. We go U10, pin 10, and then we should find C16 somewhere around here. C16 right there. Okay. So somehow that connects. So I'm going to guess there's a trace peeking out. Jeez. Oh, that's gross. So draw under C16, and then it's got to flip to here, and then it does something not amazing looking there. What's going on with that? There's a bunch of stuff bridged together. It maybe is supposed to be, but that also looks reworked. So that could be a section of interest. Yeah, definitely some signs of rework in that area. Well, I know what it does, but look at it. Look at this. It is a mess there. You know, I'm going to hazard a guess that's our problem. R30. I'm going to guess either side of R30 is our problem. Yeah. My money's on that. So we got CR8 here. Interesting. Okay. Yeah, it looks like there might be trace damage. So I just want to... Yeah, so that goes directly to that. It should go to R30, yeah, and CR8. So goes under, around to R30. And then it doesn't go to anything else, R31. Wait a minute. I think we just found the issue. Okay. Now, I'm going to make a quick measurement really here. I'm going to make a quick measurement here because I was looking at the images that I took here of this PCB, and we should have a connection between R30 and R31, and we do not. Well, now that's interesting. Huh, actually, though, perhaps not. I may have this backwards. Okay, no, we need to do Fs. Uh-oh, that looks like server-side Fs. Back again? Okay, I'm less confident that I'm correct here now. Hold on. So, R30 should connect to both sides of CR8 up above it. And it should connect on both sides. Okay. R31 would only connect to one side of R30. And then the other side would be connected to +5. Okay. Let's double check this. So let me bring that back, actually. Yeah, I could tell a server-side error because I didn't drop connection. That was weird. That was not my fault. Okay, so I can ESD strap this. Okay. Oh, YouTube also paused. Oh, well, then it was my home internet. Okay. So we should have a +5. I think this is probably that. Is that the positive side? It's not really well marked. That's positive. Okay. Okay, so positive. But yeah, maybe that one's not actual rail. It's marked minus, so. Okay, positive, positive. All right, so that's. Oh, that's right. It's super confusing. You know what? That's probably just a coincidence. Plus. Why do none of these. Hold on. That's definitely ground. Okay, so that's power. So CR8, or no, R31, one side of R31, which is this, should be connected to 5 volts. That's that side. Oh, never mind. We did not find the issue. So those are connected correctly there. All right. How about that? That is good. Okay. Never mind, I guess. This area is really messed up, though. Why is that so dirty looking? Hold on. That's a lot of dust. All right. This is what I'm looking at right now, and thinking that the issue may be somewhere around here, because that's looking pretty crusty and poorly soldered. But so far, my checks are looking good as far as how the schematic is laid out. But someone clearly had to rework that. I'm not sure why, because the parts on that one all look the same as the other one. Although maybe not the same. Ooh, actually, that's a little weird. Wait a minute. Stripey, weird, like written resistor. Weird written resistor, stripey one. It might be whatever they had on hand, or maybe they put the wrong resistors back in place after they did some rework. So R31 should be... What does TS mean? What? R30 and R31 are TS. What? Okay, well, 31 is 3.2K, 30, 1.5, 30, 1, 31, 3. Okay, weird. Test selectable? Select on test. That's terrible. Okay, so that's an example of we shouldn't swap the boards. That is super weird. Okay. All right, I want to do a little more marking here because we're almost at the point where we have everything up to the 2 control signals marked so that we actually know what we're doing. And then we can do some real testing. Okay. I just want to get... Well, we found this one. I would like to get to this because this pin, or I'd like to get here to U13. I mean, obviously we can just go look at U13 pin 2, but I would like to trace it over because if we find a problem there, maybe we need to figure out where it is in between or something. I don't know. Anyway, I know what I want to do. So U10, okay, 30, 31 just goes to +5, so that should be +5 volt. So I'll just mark that. +5V. Okay, is there TP7 somewhere around here? No, it's not. Okay. CR8. Yeah, so those connect on the inner layer. Wait, why do I have this red line right here? That should be a blue line. That should be a blue line as well. And it shouldn't be there, it should be drawn under. Oh my gosh. Okay. Resistor test select, no criteria given selection. Great. Wow, it would suck to have one of those fail and not like it blows open or something. Jeez. I'm not particularly having fun. I would like to be past this part, but I really want this part for just making it easier to go over stuff over there. Okay, R30. 30 and 31 are tied on the top. No, CR, yeah, all of that there. So draw over here to there to there. And then this will go to U12, I suspect. So let's figure that out. Draw under. So you go very, very far. I'm going to guess what pin U12? 6. Why is this footprint so weird? Oh, because there's just a bunch of resistors over there. Okay. 1, 2, 3, 4, 5, 6. So, second from the end. And then I think we can safely assume there's a straight line trace here. Okay, so that goes to U12. We don't want to measure U12 yet. We want to get to the right inhibit signal here. Maybe even right enable. Actually, we should measure both of those. So we have right inhibit and right enable, which is just frustrating. Why are there so many variations of the same thing? Okay, U12, 5. So that was 6. So 1, 2, 3, 4, 5 here. Can we see that? Kind of. We're going to have to make another guess. Or we can work backwards. Draw under. Here. Here. And then we'll go to U21. Which, let's just follow this, making the assumption. That's 18. Unless it drops down. Yep. To here. Oh my gosh. 21, 21, 21. 3, 16, 17, 18, 19, 20. Why is it over there? Okay, hold on. That doesn't make sense. 21. Pin 4. Oh man, this one's going to be a nightmare. Okay. This is draw under. Here, here, here. Holy moly. Oh, wait. Is this going to go all the way to the edge? No. I have no idea where that's going. earth. 12, no, 13. 12 to 13. Oh my god. 13 pin 3 goes here. That's not complicated at all. Okay. Manual states test selectable. Okay. Yeah, I get the write enable host commands are right. Write inhibit, yeah, doesn't allow a write. It's just weird. That's all. Okay. 13, so input was, or output is 3, and then we need 2 and 1. So let's follow 2. 2 is weird. Goes back to U12. We'll just ignore that. R45, is that? No. What? U13, pin 2 is, I guess that's the actual signal. So maybe we don't want to trace that back. Let's just get rid of all of that. That's just what we'll measure. So this is write inhibit. All right. All right. Now we'll want to go to write enable. Pin 1. Draw under blue pen. I don't think we're going to be able to see anything here. I mean, it's got to be that, but that's really, really rough. Okay, let's U21, pin 4. Okay, this makes more sense now. So here, boom, boom, boom. Okay, that definitely makes sense now. Draw over. Boom. Okay. And then 6. 6 is the input that we want to measure. So, this will be write enable. Okay. So now we can measure the signals when the computer does stuff, and then we'll be able to compare between the drives as we flip back and forth. And then if we find a place where the drives differ, we can look at the in-between things to see what they're doing. Okay. I'm going to make these be slightly more visible. And then leave it topside. Because that's all we're going to be able to see when we're working on this. Go ahead and press tab because this software is kind of weird. All right. I'm going to leave this visible like that, and then... Okay, that should be everything we need. Let's go poke it around. All right. I'm going to need the terminal in a moment, so let me make this area not as much of a nightmare. All right, protect sticker just fell off of something, or a write enable sticker, actually. I wonder which disk that fell off of. I will have to keep track of that so I don't have the error happen for the, right reason. So let me just go ahead and do this. Just going to mark the bad drive so that I know it's the bad one. Okay. Wow, that zoomed in. Does it give away which one's bad? Yeah. Oh, there was a snap in the middle I didn't even see. Whoops. Oh, or is it just a standoff? I think it's just a standoff. Okay. I kind of like this mounting solution. Okay. All right. Well, so Philip, you're saying it might have been a snap. I don't see a hole for it poking through now that I have the board in place. So I think it's just a support underneath. All right, now to figure out how I'm going to be able to connect these in such a way that we can probe from them and connect them to the logic board and power them. This is going to be interesting. You know what? Let's just connect one drive at a time. We're going to start with the good drive. And Yeah, we can just put the logic board. We can actually fully reinstall the logic board. Stupid Terminator. Thing is so loose. I swear that thing's not the problem. Is there a way I can make it press tighter? Not really. They're kind of fully pinched already. The pins just aren't long enough on this to get up into the extremely grippy part. All right, that is the logic board pinched in place and glowing green on the inside, I guess. I'm now going to connect the good drive, I guess I have to call it. And we're going to just boot from this while measuring a test point to see if it changes at all as a baseline reference. And then we will measure the bad one. And then after doing a little bit of digging, I have a couple of points that I want to check to see if different logic signals are making their way through the circuit. So we have a couple of things to probe around for here. All right. Before we probe anything, we're going to do a full boot test just to make sure that it's all set up correctly and all that fun stuff. All right, logic, this, okay. Power, boom. All right. Internal finger chopper is choppering. Computer on. Powered. Capture is switched to terminal. Terminal's not on, but I'll just hit that for when it is. We have blinky cursor. Okay. Okay. Here is our just validation test that the things that used to work still work. I don't remember if the other one makes it this far or not. We're just going to go the whole way. What? Wait a minute. Didn't mboot sys always work? Huh? Why? Why would that not be working? All right, we'll do this. Yeah, Stony might be right that the bad drive blasted mboot sys, maybe. I don't know. All right. This is going to get fun to manage. Oh my gosh, I thought this thing just died for a second. All right, so I think I can do this. Yeah. Okay. Okay, yellow is our channel 1. Okay. All right. All right, I just finished a test validation boot up to make sure everything still works. For some reason, the disk that I showed you working earlier does not, but we were able to boot from a different disk, so we're just gonna use that one for now. So we're going to reboot here. Well, I'm gonna shut everything down, and then I'm gonna hook up this oscilloscope to the right, or the erase head on here, and we'll measure to see if it does anything during the boot up process. So let me get that connected here. That's concerning, Matrox. I think I just did something weird to it, so it's fine. Please. Alright, I am looking for this. It's becoming cliche, but I have a thrift find. It just posted TT Live. That's fine. 1 second. That's right. I did something that was too much like manual labor recently, apparently, and my thumbprint got messed up, so I can't sign into my phone using my thumbprint anymore. It's very annoying. IBM thermal printer. What's the interface? You know what? Just yes. Oh, well, Kaiser may have beat me to it. There's a real good chance that is meant for the PC Junior. Parallel. Interesting. Okay, I'm just gonna make sure I have a good ground. Easiac, are you still here? Because I keep finding horse-hairs on this thing. Starting to think horsehair brush ain't that great. Let's clip this to here, which is ground. Okay, so test point 6. That got us what? Can't see because I don't have that part. Oh, but I can see up there. Test point 6 is kind of the digitized version, but there's no standoff, so you know what? We're not going to actually use that. Time specifically PC Junior. I had a feeling. It seemed very PC Junior-y to me. Okay. I think that's good. Disk is in there, I believe. Yeah, whatever, just leave it. Okay. Looks like the same store for a PC Junior. I bought mine at Goodwill. It was in an Epson MX80 box. Okay, I have the multimeter and the oscilloscope here connected to the head output directly for erase. When we turn this on, we will see this jump up to 12 volts. I'm not quite sure why I'm not seeing anything at all over here. That's a little weird. Let's auto set on that. Let's measure. Let's see. First off, are we DC coupled? Let's look at that. We are DC coupled. Okay, so measure. Maybe just high. Channel 1, 1.4 volts. Well, that's weird. Why? Yet again, I'm having this thing be annoying. So we are at 500 millivolts per division. It thinks it's at 1.4 volts. Do I need to set a what you call it? The 1x, 10x thing on here? Is that what the problem is? Because this looks like 1/10 to me. I don't know how to do that on here though. Fine scale, position, offset, clear, vertical menu. Oh, why has it always got to be so complicated? Yeah, I don't know if it's probe scaling or what, but it needs to be set to 10x mode, I think. I don't know how it hasn't been this whole time. Could also just click 1x. There we go. Good enough at 1x. Alrighty. Alright, so just can't remember where the setting is. Yeah, it's complicated because it got like 6 different menus. Utility. No. I don't know why it's not in vertical. Invert. Bandwidth. Fine scale. Division. It's not that. If you aren't looking at super fast signals, I actually have no idea how fast it's going to be. All right. So that's the drive running. I'm going to turn on the computer. And we should be booted. Now I'm going to go over to the terminal and I'm going to run 33L and we're going to see if anything changes. I'm going to go ahead and set this thing to also keep min-max. Why not? Just in case it catches something that doesn't. I didn't realize that could do that. I wouldn't have bothered with the other thing. All right. $33L. Seems like it's stuck now. I'm gonna guess we can't probe directly on the head. Maybe we're loading it weirdly or something. It is holding at the date question. It's never going... Yeah, see, that's different. That did something weird. Okay, I'm going to shut everything down, disconnect the drives for the measurement stuff. Try that one more time. This also invalidates the test from yesterday. Come on. Okay, we might be writing some new disks here. While that's going, I'm going to rewrite the mboot sys disk. No, we can't connect the drives to the grease weasels. They have an unknown weird pinout that has DC voltages going over the 50-pin connector. Weird. All right, well, I'm going to give up on it, I suppose. All right. No interference test. Why is it not booting? Case maybe doesn't like being on its side for some reason. Dude, you are a very confusing computer. It's gonna make probing real hard. No, Bennett. All right, this is becoming difficult. No, that was an actual boot attempt there that says disk status error, which I'm not sure is a thing we've ever seen. I just rewrote that disk. I don't like what's happening here. What's going on? Why is this not working now? That was just two different disks. That's a good point, Philip. I think the terminator was loose. Dude, that terminator thing is really frustrating. We're going to spend a moment on that. So, it's a small PCB that has a resistor pack and a couple of other loose resistors on it. But there are holes on the bottom here that go into these female pin sockets on the top. The female pin sockets only pinch down right at the very top, underneath of that lip right there. So the pins need to basically go all the way through it. Now, this was originally designed to go onto the back plane where the pins are like super long and they actually poke up through this. They're not really great for just like pins sticking out of a board that aren't super sharp. Like the ones over here, where they aren't particularly long. And when I go to install the terminator, it also gets hung up on this glue holding on that piece of FR2 or whatever to shield, and it never goes on like really tight because the pins don't stick out enough. I mean, you can see how short down those pins are. So I'm not sure how we can do that without trying to just like push the pinch point down lower by messing with those. And I'm not really thrilled about that. Even at that, even down there, it's not like really flush. This is bad design. I don't want to glue it in place because we're not making very good contact to begin with. Yeah, I don't know if I can turn it around. I don't know if it's symmetric. Even if it was, I don't even know how well it'll fit. Like we're powered off right now. Oh my gosh, that is a nightmare to align. Oh no, we can't because the pins reach each other at that point. No, that's impossible. So yeah, this is that's awful. Yeah, there actually is a schematic for this Terminator. We could make a new one. I don't want to. So, no. I just wish that the pin situation was better. For everyone saying to glue it down, no, this thing is not going to live here permanently. So I don't want to. Just wish I could think of a better solution for this. Yeah, so this isn't where this the Terminator normally goes. This normally goes on the back of the hard drive. That's why it's not gonna stay here. Problem is, even if I had, like, if I made, like, extension pins, they're still not going to be long enough. I don't have pins that are long enough for that. It just goes in so weird. Dang it. Is that spider webbing all around it too?
CHER 100, so weird is normal for this though.
End of line.
Chloe, thank you for the 100 bits. I have an idea. Oh, I don't know what they are, but maybe it'll still work if I do it a different way. So we have those exposed pins. What if I grabbed a PC jumper, put it on upside down. Oh my gosh, it's just loose. And I can't bridge those because they're part of the, like, signal stuff. They're kind of, you know, important or whatever. Maybe this way. No, that doesn't hold it on well enough. Ah, man, I thought I was onto something there. It's a good semi-permanent solution. I like how this just completely covers this chip footprint too. All right, we're just gonna do the lame solution because I don't have a better idea. Oh, that sucks. That's awful. This is terrible. This isn't gonna work. This is useless. No. It doesn't stick. Well, it's not necessarily that it would be on its side either. I mean, that will help. But it's still loose. It's still a bad design. The pins don't stick up enough to actually reach the parts that clamp down. This solution also sucks, but it's going to work better. Ah, no, it doesn't work either. It can't... Nothing will stick to this PCB. The surface of it is too awful. And I can't lay it flat, because then the cables won't reach. All right, I got one other idea.
Belgium at subbed as Prime and says here, have an amusing sub-message to detract from the ongoing horrors being visited upon you by the data general. Hang on, wait a minute, I'm sure I'll think of one in a moment, maybe not, sorry,
End of line.
And thank you for the Prime sub. And for 27 months. I appreciate that. All right. Oh my gosh. This is terrible. Ugh. Drive repair is ongoing. It's just delayed because of the stupid termination pack not staying in place. So I'm trying to get a wire to wrap around it. No, the good drive just booted, Ben. It booted once, but only after I repressed the terminator back in. I'm not even sure I'm actually rotating this stupid thing. Oh, that's starting to hold pretty well. There we go. This is solid core wire, by the way, so no, we don't need to tie anything. That should do it. I just need to make sure that the wire doesn't touch anything. That's actually pretty good now. All right. Okay. Let's try both discs now. I don't know why I put it on the ESC strap. I'm going to have to walk all the way around to the terminal again. Okay. All right. One works. Release DP0. Let's do this all fancy like. Okay. Let's swap disks. Mboot sys. This won't have fixed the second drive. No, the second drive has deeper issues. I would just like the thing to work consistently. On the one good drive. Those are interesting sounds. But it worked. Okay. Ah. All we did was change the terminator, or like re-secure it. So stupid. All right. Blah. I need this. Not that. This. There we go. Okay. So, but not the floppy writing folder. I need schematics and test points and readings. Okay. We need to see what... How long does the channel 1 max or the maximum reading stay on the oscilloscope? Because I'm just noticing that it changes. All right, try the drive on its side. You know, that actually is a good point. We should do that. I'm going to do full power cycle and try that. I expect it will work. But it would be smarter to just rule out first. Now, you just have to take my word whether or not it boots. Video capture stuff sucks. Yeah, so Philip, the terminator is because the Micronova uses a differential signaling bus for the backplane. The backplane is actually exposed on that ribbon cable that goes next to the terminator, and the card in the floppy drive chassis is the floppy controller. So it's not, you know, just like the drive interface. It's actually the floppy controller. So that having an unreliable connection to the main system would cause, you know, problems. Okay, that was a good test. Release DP0. Okay, it booted. No problems. I don't know why I released. I mean, I guess I'll make it happy when I turn it off, but... Alright. Drive off. Computer off. Okay, let's try this one more time. We're going to use the oscilloscope, though. All right, so I want to probe erase inhibit, or maybe write enable. Let's probe write enable. So that's somewhere. Write enable is 2 chips away from the cool one, and it's the second pin from the bottom. And by bottom, I mean don't listen to any words I ever say, because they're all meaningless. Is that touching or not? I don't like that. Now they're definitely 1X probes. Okay. And then ground somehow, somewhere, sometime, someplace. Right there. Okay. So this will be right enable. Let me bring up the oscilloscope for you. All right. We're going to test the right enable pin on the good drive. So we are measuring it with an oscilloscope, and we're going to check the voltage level. I don't know why it's saying there's 2.4 volts on the bus right now. I don't think that's true, but we'll find out once we turn this on, if it changes. There we go, went up to 5. That seems a little more reasonable. And we'll see what that does as I turn on the computer and then go tell it to boot. All right, computer is ready. Don't smoke while cleaning the heads, that's amazing. All right, so now I'm gonna flip my view screen here so I can see this. I just realized I've still had the camera in the way. It could have been blocking my face so much. 33L. Once we get past the file name dialog, I want to see if we get any right enables. Okay, I don't know that the oscilloscope reading is valid. I'm going to repeat that with the multimeter. Just for giggles, we'll run a list. I think that modifies stuff with the right. Minimum was 3. That's something. Release. DP0. That should definitely write. I guess I need to clear this. All right, 33L. That's what I'm thinking, Majinko, but on both devices. Oh. I swear I saw a value lower than 3.4 on the display. All right, here we go. Single shot falling edge trigger, I like it. We'll do that after this. Yeah, all that does is tell us it wasn't the same thing. I keep wanting to say do release, like I'm doing a do release upgrade on Ubuntu. Release DP0. Okay, let me set up the scope. Trigger, slope, falling, level. Let's say 3.5. All right, source 1, coupling, okay. Type. Edge, source, mode. No. Trigger on. Type video. Video versus edge. That's weird. Mode. Normal? Choir. Source. So we're at 500 microseconds. 20 milliseconds per division. Okay, let's go 10 milliseconds per division. Okay, I think it's waiting for a trigger now. Okay, I'm hitting mboot sys now. Okay. We got a hit. Sorry, 188. Let's see if we get another hit. I don't know if it will automatically re-trigger, but I'm just curious. 1, 1, 1. Okay, here we go. Continuing. Okay, so it will update every time it writes. Okay, that's good. That's helpful. Okay. Okay. Don't like the offset? This is the working drive. So I don't really care right now. That's whatever. Okay. Ugh. All right. One moment. Really gross. Where do I put those? Drat. Who let me organize stuff? Oh, there we go. I don't get it to show this. Oh, it hasn't triggered, so it won't show the second one. Okay. Turning off the drive. And I'm going to connect to the erase head because I want to see that. And we got our fall. Okay, so that's good. Turn the drive. I'm going to turn the computer off now because I'm an idiot. Okay. Turning the drive back on. Turning the computer back on. Okay. So 33L, I think we will get a signal. So I just want to see what the state of the erase head is when it actually goes to do an erase or a write. I have to go tell it mboot sys. One moment. Just wanted to get this somewhere a little more safe. Also, I should turn it off. All right, I think we get it right during this process. Okay. Whoa, that's high. I guess that makes sense. Okay, I brought the scale down on the second channel, 5 volts per division. And I hopefully increased the window. I don't know if it'll be enough. Well, I have a couple of shots here, so I should be ready. Okay. Not seeing anything. Okay, I'm running list. Set on an I don't know why I would use tape. Unless you're really far back and are still looking at the Terminator thing. Drive exerciser to test these. Yeah, it does kind of suck. I can't just arbitrarily test it. Wow, I'm not seeing anything on the erase head. That's weird. So that completely invalidates the test from yesterday. Great. All right, well, let's check the other one. So I want write inhibit. So let me turn everything off. Rather than measure the head, I'm going to go over to that one. I'm going to measure the second pin. Oh gosh, this one hasn't been bent. Measure the second pin from the bottom. Okay. No, I'm probing the correct pin for the erase head. Okay. Computer. Right inhibit and make more sense to check. Yeah, there's, you know, going through the options. Now that we're here, we're probing and the drive is working. The two channels should have shared ground, so that shouldn't be necessary. All right, real curious what we're going to get here. Flat line, okay. Let's measure channel 2. And then that's TTL. So channel 2 should be, it's 5 volts per division, the same as the other one. Okay. Weird. Okay, so right inhibit is 3.3. That's kind of strange. All right. I entered the date. No change. Huh. Weird. Okay. I have no idea where right inhibit comes from. All right, I think I need better probes. But right, it's not being inhibited, so that's good in my book. Yeah, I suppose. Yeah, we could check this on the other drive, but I think I want to... I think I would... I don't know how to set this to 10x probe setting. That's why we're using 1x probes. That and then the probe connectors are enormous. Pin 4, schematics, sheet 3. What? U12, pin 4. something or another. Nerd speak. Okay. TDS 320. See schematic sheet 3. 1, 2, 3. Bottom left. Went to the wrong thing. U12. 1, 2, 3. Bottom left. U12. What about it? Oh, Phil's right. Yeah, channel 7 scope that you use. Where are you seeing U12 and why? Door unlocks. See U13. That's what generates right inhibit. Oh, okay. I'm still not seeing U12. Hold on. You meant the second sheet of the schematics. Okay. Right inhibit. Got it. U12. Are we involved with U12? I think we are. Hold on. Bring back my stupid controls thing. Here. Okay, one moment. I know you can't see. U12. That's what wait, hold on. Bottom side. Okay. Oh, wait, no, we're not doing anything with that. Okay, never mind. All right, I have better tech probes. I have a lot of better tech probes. I have a better tech. I've never used it. It's one of those things where the instant you guys see this thing, you're going to be like, yes, do that now, please, fun, cool, awesome. And I'm going to say, slow your roll. Oh, you can't see anything. Ha ha! Foiled! So, this is a Tektronix 7904 oscilloscope mainframe doodad, a majigger. It's supposedly a storage scope. It's got probe modules. Here's the thing. I've never powered this. And I got the feeling this is one of them things that you want to, like, reform and check the power supply and all that fun stuff. So we're not going to power it. But it did come with a bajillion probes. A bajillion. So I should have tech 10x probes in here. It gets even crazier than that. Let me see if I can find the cool one. Yeah, that's it. Any of you seen one of those? So that goes to where is it?
Oraku says CHEER 100 that scope is big enough you could attach a motor and drive it around.
End of line.
All right, that goes to this. Current probe amplifier. So you plug this in and then you can, I guess, measure current waveforms, which is really weird. So yeah, that's that thing. So yeah, but I should just have some like normal probes. That's, I don't know what that thing is. That's not a normal probe. That one is, okay. So we got a 10x, just standard tech probe here. That should be good. Do I have a differential probe? Wait, the probes for differential scopes are different? I have a Tech 503. That is a differential oscilloscope. It does not work, though. I did plug that one in, and it's full of them tubes. So I don't know if it'll ever work. First, adjust the probe compensation before using it. What, you want me to get the sine wave generator thing and not generate a sine wave, generate a square wave? So I know there are some probe add-on things. Termination for current probe. Oh, okay. That's what that is. What's this? Probe. That one's broken. That sucks. Oh, that's just, yeah, you just replace that. Okay, I got no idea what this thing is. It's a Tektronix offset probe. That's weird. Why? HF term, DC, a 10, 1 meg, 10 PF. What's this, a 1 meg? This thing's got weird stuff in here, man. Let me get 2 of the normal probes out. Make sure they got the ground clip on at least one of them. And the clippy clip thing. That one's missing the collar. I do not have a lot of the probe collars, it seems. Oh, is that what that is? Wait, what? Okay, I don't know. Things are weird in this. Too many stuffs. Hold on. This is the quote-unquote good one. Set that aside. And then I need this collar and that ground connection. Gimme. Okay. One ground, one collar, and then another probe. Okay. Well, I think that'll do it. Well, it's mostly YouTube chat that's delayed.
77 SICHEER 100. Are we on a tech tangent right now?
End of line.
Not necessarily a tangent, because I do actually need these. Because I think whoever commented that it's a tech scope and it like auto sets 10x mode is right. That's how the 465 works. Because they're mean. Okay. Put the collar back, the little pin inside. Plastic, the B and C plug, I don't know. Keeps telling me somewhere in the menu for the channel there should be. Yeah, but I didn't see it. I feel like I went through all of the relevant menus. It just didn't exist. Get the stupid probes out of here. Oh, I guess we got the 10x or the calibration thing. We can use that. And I just dropped the hook. Get that back in a second. All right. Get back there. Okay. All right, come on, HB. Wait, these don't have the weird pin. They're just always 10x. Also, they're 2 meter? I might be putting these on the 16500C. Did any of them have the pin? Oh, wait, no, those definitely do. No, these don't have the pin. What? Why? Well, that sucks. Okay, I guess I own one of those. And I don't know that it's in the office. All right, hold on. Do this and that. And this. And this. Not that. That. Okay. So you want probe comp. There you go. That's a really nice grounds connector. They don't have the sense pin, they're older probes. I mean, yeah, that sounds about right. Dude, why? There we go. Now I kind of want to juice the other one and see what it looks like when it's all crazy. Yeah, I'm rounding it a little bit. There we go. Okay. How do I figure out why there is such an offset with no probe connected? What do you mean offset? Because I wiggled the position thing? It is DC coupled. Okay, let's try some better probes. What do we want to measure? All right, well, that's good to know that it's only for this scope. on the calibration. Why are we tinkering with probes? Because I don't know, man. Trying to get a baseline of what a good read looks like. Dude, that hook is huge. I know. I accidentally got some of these, and I was like, these are terrible. But no, they're perfect. They're probe clips, but instead of having pins on the top, they're like little nails. They have a head so that you can clip a probe onto it, and it can't slide off the edge. So it's not meant for logic analyzers. It's just meant for like oscilloscopes. So that's exactly what we need here. Where do you find those clips? The past? I don't know what to tell you. Yeah, I may have some dip clips. I also have some SOIC clips. These ones are not as useful to me. Okay. And just to make Ben sad. Okay. Anyway, what do we want to measure? I have a full set for mine. I have to try harder than that. Not by much. Okay. I think the right protect light worked okay. Pin 3 and 4 U12 should be an inverter. All right. Oh, yeah, I was looking at that. What do we want to measure? I kind of want to measure TP6. Like, I know it's, like, not necessary, but I want to measure it. Handy. Okay, TP6 connects to pin 2. Let's just go ahead and grab onto that. Okay. And then for the other one that we got to use, oh, that's too big. That literally won't fit. Yeah, so this is one of the things that sucks about dip clips. I didn't realize this until it was too late. This is a wide one, so it will just fall off of any of the chips on this thing. So can't use that one, which means I'm going to use a normal one. That's SOIC. Okay. That one's kind of looky. That's a big one. That's a big one. That's a narrow one. Ugh. Oh my gosh. I don't know how to calibrate the thing. Does it really matter? If I don't see calibration here, I'm not doing it. Yeah, I don't see it. We're not doing it. Okay. So that is TP6, okay. Well, let's do write enable, because that's the only one that actually works. So that's the second chip over here. And from the top, it's the second pin down. Although we should swap these, because I have it set up to trigger on channel 1. Or at least I did. I don't know if it still is. Trigger menu. Let's see, run stop. Mode, normal. Slope. Falling, level. 3.5. Okay. TTL. Not 1.4 though. That's too. Hold on, clear. 5 volt per division. 5 volt trigger. .6, that's good. Okay. Clear, and then run, stop, trig. Okay. Boop. There's an option W4 to enable write protect sensor, W5 to enable it. Is W4? What? Where? W4, W5. I could totally see them having some stupid setup where they asked the data general tech to disable writing on one of the drives, so I could absolutely see that. Bank of 3 resistors, R330. What? Hold on. I know the overlay's over there. I can't. Well, maybe I can't do it without getting up. Hold on. No. Oh, no. I made it worse. There. Next to U12. W3, W4. Okay, hold on. What page talks about that? What do you mean 3 of 6? Oh, literally the page I'm on. W4, W5. Well, we have W5. Here, let me take off all the junk. So yeah, there's W5. We have it. W4 needs to be fitted, W5 needs to be absent. Really? You sure about that? Oh my gosh, I'm recording. Great. That's a lot of wasted footage. Yeah, so there's the live drive. It has W5 as well. So I don't think that's it. They're identical. Both of them have W5. The other doesn't have W4. Phil, the computer requires write to be able to boot. Now, that section has never been modified, so there's nothing weird about that. I'm saying both drives are the same. And they're both set to that. You probe pin 4 and U12 against write enable. Okay. U12. Oh, no. I think that's the one that's right next to the write enable chip. That's going to be a pain in the butt. Oh, no, it's a little far over. Okay. Okay, hold on. Let me double. I think my trigger's all correct. Okay. 33L. You don't get to see the oscilloscope. I'm mad. Grrr. There you go. Mboot sys. I think I screwed something up. Because write protect didn't do anything. Why didn't it trip it? Trigger menu, DC, negative slope, mode normal, edge, trigger. Mode auto. I still think it's not in 10x mode. That's right. Vertical menu. Dude, I got no idea. The probes are 10x. Why am I fixated on 10x? Because we are attenuating the signal down by 10 times right now. So we're not getting a readable value. Yes, we're still probing the working drive. No space X does not appear in the TDS 320 manual. What? Change my vertical scale to 500 millivolts. Oh my gosh. Ah! Channel 1. Channel 2. Trigger. Level. Gross. Okay, fine. Run, stop. Trigger. Mode. Normal. Clear. Go. Okay. Let me run list. We'll see if it does anything. Oh, it wants a date. Hold on. And a time. I think I'm on the correct pin. Right enables, second pin down. Okay, I'm too close or too tight on the timing. Okay, I'm going to set it to 50 milliseconds per division. Now I'm going to run list, which I think does right. All right, there you go. So now you want to see pin 3. Okay, that's not how you do that. U13 pin 3, right inhibit and right enable are combined. All right. Who keeps changing my view over here? About ready to just print this out. Okay, 13. You want pin 3. Okay, so that's actually correct still. All right, go pin 3. Nothing. Okay, what's wrong with channel 2? I'm vetoing the next test. The next test is channel 2 shares channel 1 signal, and we compare the two, because I feel like it's screwed. What? I don't know what the deal is. All right. This is becoming a long-form project. Here's the thing. I'm done using the scope for this for today. I'm going to use the HP 16500B. We don't have time to set that up. We got 11 minutes, man. we don't have time. Give with one hand, take with the other. Yeah. I don't have video capture on it. There's this giant drive chassis in the way, so I can't show it to you when I'm using it. So the solution is use the 16500C that's over here. Well, it can't reach anything because it's all the way over there. So I think, I don't know if you're still here, Wesley. I think it's time for this thing to be put into service. I'm going to VGA mod the 16500B. We're not doing it now. I'm going to have to do it off camera at some point. I don't know when, because I'm probably going home and editing. But I'm going to cram this inside the 16500B, just like we did the C. And then I will be able to get VGA out of it, and we can capture it, and then we can actually use it. But we don't have time for that. So I'm trying to set up now in such a way that this project is not left in an unresumable state. Still hear audio only mostly? Okay, well that was the VGA splitter that you gave me. It will be getting utilized. The failure is in the not understanding my tools and making bad readings and assumptions based on the readings. I am not slowing down enough to understand the process, which is what I was trying to do by making the diagram earlier today. I was trying to slow the process down so I could understand what we're reading and where. And then we started going off of that, and then we involved a tool that I'm not very comfortable with.
Oracoon says CHEER 100 yes. Leave making bad assumptions to chat.
End of line.
Chloe, thank you for the 100 bits. So I need to go slower, use the better logic analyzer. But then we will want to continue this on camera, and that's really difficult with that logic analyzer. I'm also tempted to swap the B and the C.
LUCAYBOB 77 SICHEER 100. Here's another 100 from the peanut gallery.
End of line.
Lucky Bob, thank you for the 100 bits. You're not a bad influence, but it just becomes... It's difficult to stay on course. That's the thing. So I need to better define my course for complicated debugging like this. And I need to better understand my tools. Five of 6, 38, logic flow, of error conditions. We can look at that here really quick. Looks like I can just do this. No, I can't. Why? Because I need to do this. Yeah, they definitely take time, and they take patience. Yeah. Okay. 5 of 6. What about it? Page 38. Hold on. 38. I don't see a logic flow. What are you looking at? Logic flow of the error conditions and their signal sources. I'm not sure I follow. I like how there's a line that's just called pull up. Why is that a net? Yeah, the streaming really doesn't help. Again, it's no one's fault. It is just extremely difficult to concentrate while you're doing a live broadcast. It's difficult enough while you're just recording. That's why you'll see, like, the video will be, I'll get back to you, you know, once I've made some progress, and then the progress is, I'm done, I figured it out. Because it's not like an incremental thing. Is this it? No. Is this it? No. So, I know, but it's just pull up as a net is hilarious. So one of the benefits of using the 16500 series will be that I can set up a probe. Not feeling guilty? Yeah, give it a quick recap at the top of the next one. Yeah, absolutely. Don't feel guilty. Needs a break to do something else. Yeah, I've now been here at the office for 8 hours, so yeah, I need a break. No, I don't want to reduce chat down. If I'm doing anything like that, then I'm doing no chat. Or like TTS only. That was actually a thought I had recently of doing something like that. The problem, though, is trying to fill the dead air, less than trying to read and respond to chat. Because I'm constantly trying to fill the time with something as I'm going along, and that means that I'm speaking, but I don't necessarily have something to say. Because I'm trying to figure out a problem. And then when we get to this stuff, there's so many things where it's replace PC board. They don't actually troubleshoot anything. And I realistically wouldn't be surprised if the real logic flow was customer has complaint, replace PC board. Because when you're not doing, real board level diagnostics on site, like half of the calls of the data general text and the service notes are replaced. I mean, they're not actually doing real work on this stuff, so this isn't necessarily meant for that. Yeah, actually, 0 ohms is on an interesting point there. This supposedly could be configured with a runtime counter, which is crazy. So. Yeah, like, see, these are a bunch of words that are probably, like, important or whatever. I'm not going to sit here and read this on stream. So, yeah, we'll figure it out. Or maybe I'll spend all week editing videos and I won't have any time to, and I'll come back and just be as confused and unable to continue as I am right now. Who knows? Because I don't get to spend all of my time on this, even when this is all I do, as weird as that sounds. So, nothing particularly useful. Delightful. So, all right. We are going to run the outro here. This is floppy drive. It works like any other floppy drive. Great. Good way for us to spend 4 hours to do nothing. Well, what did we do? We secured the Terminator.
Ultimate says cheers for the stream, Shelby, and don't let it get you down. CHER 100.
End of line.
Ben, thank you for the 100 bits. No, I don't really feel down about it. I think it's because we did spin our wheels so much, but oh well. Yeah. All right, it's outro time. That's the intro. That's the outro. And now it's being wonky because I hit the wrong thing. Touchscreen makes that difficult. All right. Well, I don't know. We'll see what happens. I would like to work on this. I have other things that I have to do. I have another video I have to edit because, you know, we've been doing this non-stop for a month now. I have a lot of footage from that. So, yep. Well, I don't know if I'll have time to get to this week. That's fun. So, all right, anyway, if you all enjoyed this stream, you may want to follow to be notified when I go live again next. If you want to help support the channel, you can find me on Patreon. But that is it for now. To be continued, etc., etc. And I will see you next time. One of these days, the printout will work.
Thank you.